Okay, this is the Cambridge IGCSE Additional Mathematics Syllabus 0606, October-November 2022, Paper 2, Variant number 3, Question 9. Now the equation of a curve is y equals to kx e to the power negative 2x, where k is a constant, and part A wants us to find dy dx. So I have this equation, and I have to find dy dx. So to differentiate y with respect to x, and since I have one over here and another one over here, thus I have to use the product rule to differentiate this function. So I have u and v prime plus v and u prime. So here I have u v prime, v u prime, which is the definition for product rule. So eventually this is what the derivative will look like. So it'd be negative 2kx e to the power of negative 2x plus k e to the power of negative 2x. And this is my final answer. Part B wants you to find the coordinates of the stationary point on the curve y equals to 10x e to the power of negative 2x. So for the stationary point, this means that my derivative will be equal to 0. And then I have 10x e to the power of 2x. So basically what this means is that k is actually substituted with 10. So in this case, k is equal to 10. So what I can do is that I can bring my answer from part A to find dy dx for this function over here. And I know that dy dx from the earlier part, negative 2, 10x e to the power of negative 2x plus 10 e to the power of negative 2x. So this is what it will look like, negative 20 x e to the power of negative 2x plus 10 e to the power of negative 2x. And then I have to find the coordinates of the stationary point. So at the stationary point, my derivative dy dx is equal to 0. So I'll have this. What I can do is I can factorize out an e to the power of negative 2x. So in the bracket, I'll be left with 20x, negative 20x plus 10, which is equal to 0. So I have e to the power of negative 2x is equal to 0, which is not possible because e to the power of negative 2x is actually always more than 0. It can never reach 0 in this case. So for e to the power of x, be it in this shape or be it in this shape, it will never reach 0, which is the x-axis. So that is the definition for this part over here, about e to the power of 2x being more than 0. And that leaves me with negative 20x plus 10, which is equal to 0. So I can find negative 20x, negative 10, divide both sides by negative 20. So I'll be left with x is equal to half. And this is my x coordinate of the stationary point. So then I have to substitute x is equal to half into y. And y is 10x e to the power of 2x, 10x e to the power of negative 2x So 10 times half will be 5 e to the power negative 1, which is 5 over e. And hence my coordinates of the stationary points will be half 5 over e. And that is part B. Part C. Use your answer to part A to find the integral of 4x e to the power negative 2x dx. Now to use my answer from part A over here. And then I have 4x e to the power negative 2x. So I have to find the x term in this case. I will actually copy my answer from part A and say that the integral of negative 2kx e to the power negative 2x plus k e to the power negative 2x dx. Ensure you copy it correctly. So give you kx e to the power negative 2x plus c. Just bracket this. So this question is actually all about integration as the reverse process of differentiation. And I want to find the integral of 4x e to the power negative 2x. So if we compare this one over here, I will take the coefficient of that 1 right to 4. And then what I'll do is I'll simply just find k by dividing both sides by negative 2. I'll get k equals negative 2. So I'll substitute k equals to negative 2. So the integral of... Sorry, my integral sign is not very nice. I want to make it nicer. So it'll be 4x e to the power negative 2x. K is negative 2, so that one is negative 2. So 2x dx. Negative 2x e to the power negative 2x plus c. Then I can split this into two separate integrals. Minus integral of 2e 2x dx. So this is negative 2x e to the power negative 2x plus c. And then afterwards I can shift this over to the other side. On one side I have the integral that I have to find, which is this. So it'll be negative 2x e to the power negative 2x plus the integral of 2e negative 2x dx plus c. And so eventually this is what the final answer would be. Gosh, that's a horrible integration sign. Yeah, I tend to be a bit more nitpicky when it comes to drawing my integral sign. I want it to look as nice as possible, but this is not really working out. Oh well, I'll just leave it as it is. So 4x e to the power negative 2x dx will be equal to negative 2x e to the power negative 2x. So if I want to integrate this one on the other side, so it will be plus 2. And then I'll put 1 over negative 2 e to the power negative 2x plus c. So it should give me negative e to the power negative 2x plus c. And then this should be my final answer. That's part C. Part D wants you to find the exact value of this. In this case, we have an upper and a lower limit, so we are dealing with definite integrals over here. I can use my answer from part C to help me find the integral 0 to 1 4x e to the power negative 2x dx. And then I'll use this 2x e to the power negative 2x minus e negative 2x. Since we are dealing with definite integrals, we can disregard our arbitrary constant c, which is this one over here. We can disregard that in the case of definite integrals. So it will be negative 2, 1 negative 2, 1, minus e to the power negative 2, 1, minus, and then the other side I have negative 2, 0, e to the power negative 2, 0, minus e to the power negative 2, bracket 0. So on one hand, I'll have negative 2, e to the power negative 2, minus e to the power negative 2. So on the other side, negative 2 times 0 times e to the power negative 2, 0, that will be 0. Negative e to the power negative 2, 0 will give me negative 1. And I have a negative bracket outside, so it will be a plus 1. So in this case, they should give me negative 3 e negative 2 plus 1. Then the final answer will be negative 3 over e squared plus 1. And that is part D. And overall, question number 9.